go ahead and get things started then for this evening with the Virtual Storm Spotter Training Spring 2022. So for anybody that's not familiar with using the GoToWebinar interface, there will be a section in there for posting questions labeled the question section. This is where you'll be able to ask any questions throughout the entire presentation, and Corey will be able to help you out with those. Also a reminder, all attendees will be muted through the webinar to prevent any kind of background noise in the presentation. So we'll start off with what this course is not. To begin, it is not going to be discussing how you can get sucked up into a tornado like Dorothy did in Kansas. And it is also not a presentation on how to get into the middle of a tornado just like they did in Twister and throw some science objects up into the tornado. So that is what this course will not be. So here's a look at the 7 different topics we're going to cover this evening. Over the next hour, we will first talk about the NWS and what we do at the National Weather Service. Then we will take a look at the spring 2022 outlook, even though we're kind of already a month into that here, meteorological spring, month and a half almost. We'll take a look at forecasting severe weather, the different severe weather products that we issue here at the Weather Service. Then we'll really start to dig into storm spotter information such as identifying storm types and futures, and then how to send us storm reports, what to report to us, and finally wrap up the presentation with severe weather safety and preparedness. So let's kick off with a poll here. Corey will be launching that poll here for us, and you'll see it pop up on your screens. How many tornadoes occurred in the Springfield County warning area in 2021? Would that be A10, B15, C20, or D25? So we'll give it about a minute or so for the answers to come in, and just let me know when most of the answers are in, Corey, and what the majority of the poll picks.
All right, so sitting at about 2/3 of people voted. We'll give it another 10 or 15 seconds here. All right, looks like 77% of people voted. It should be good enough here. I'm going to close the poll. It looks like the majority said 44% of them said 15 for a number of tornadoes. You also had a large grouping of about a quarter of the audience that said 10 and another quarter that said 20.
All right, thank you very much, Corey. So the final answer, the correct answer would have been 15 tornadoes were surveyed and documented in the county warning area for 2021. So we'll see how that stacks up against this year as we begin to dig into spring 2022 with a outlook for severe weather across our area tomorrow, starting as soon as tomorrow. So let's talk a little bit about the National Weather Service and what we do. Our mission is to provide weather, water, and climate data, forecasts, warnings, and impact decision support services for the protection of life, property, and the enhancement of the national economy. And to kind of put that into lay terms as far as our vision, so to say, we're looking to build a weather-ready nation. So this is a society that is prepared for and responds to the weather, water, climate-dependent events, and is prepared for and resilient against those particular events. So we are part of the Department of Commerce, which is part of NOAA, the National Oceanic and Atmospheric Administration, and we are the 3rd branch of that down there. It's the National Weather Service. We are one of over 100 National Weather Service offices across the entire country, right here across the Midwest region of Southeast Kansas and Southwest Missouri. So taking a closer look at that, this area outlined in the yellow represents our area that we cover. This includes 3 counties in Southeast Kansas and 34 counties in portions of Southwest, Central, and South Central Missouri. So this is a great map for any of you that may be new to the area to get familiar with what counties may be downstream of you in the event of warnings being issued. So let's take a quick look at the spring 2022 outlook. In general, we are looking at favorable for above normal temperatures and generally equal chances for to below normal precipitation, and that is looking at for the April, May, and June time frame. So even starting to get into the start of summer. And to go along with that, we're in a La Nina pattern. So that is highlighted here in the yellow box there. So what exactly does favoring the La Nina pattern mean? This is what a La Nina pattern typically would look like with the dashed arrow line there representing the jet stream. And that's going to be pretty variable. So you're going to have your shots at seeing, some active weather move through. For instance, how we've been generally the last 1 to 2 weeks with some active weather. So you're also going to have your bouts with warmer to cooler weather back and forth with that variable jet. And in general, the wettest conditions are going to be found across the Ohio Valley region, and generally drier as you get further south into the southern plains and portions of southwest Missouri with La Nina, or southwest United States with a La Nina pattern. So now we're going to dig a little bit into forecasting severe weather. What are all the ingredients that you need for a good severe setup? So this is just a diagram that gives you a little bit of everything of what goes into forecasting severe weather. You need the Gulf moisture, the warm push of air into the area, low pressure system, you have a jet stream. So how do we analyze all that at the National Weather Service? Well, there's 4 particular ingredients that we really want to dive into as far as assessing the atmosphere for thunderstorms and in particular severe weather chances. So first is going to be moisture. We'll kind of analyze what we need to look at from a moisture aspect. Next, you'll be taking a look at instability. You're going to need a lifting mechanism as well. And then lastly, when it all comes together for getting organized thunderstorm activity and potentially strong to severe thunderstorms, that leads to our need for storm spotting and such, we need the presence of wind shear in the atmosphere. So first, taking a look at assessing moisture. How much moisture is available in the atmosphere to support thunderstorms? You're generally going to start to see moisture increase, and one of the big things that you're going to really realize from a real life aspect of analyzing the moisture in the atmosphere is what are the dew points? You hear meteorologists talk about the dew points all the time. So once you start getting those dew points greater than 55, especially once you get into the 60s, even the low 70 dew points, that's when it really starts to feel, you hear people say sticky outside. You really feel that humidity and the moisture in the air outside that's conducive for thunderstorms. Next, we assess the instability in the atmosphere. So our way of doing this is we analyze what is known as CAPE, or convective available potential energy. And this diagram on the far right-hand side kind of is our measure of CAPE values. And we're able to analyze that through various models and diagrams and such that actually give us an idea of how unstable or how stable the atmosphere is. So the greater the instability, the more the environment will be conducive for thunderstorm development and potentially support strong to severe thunderstorms. Then we're talking about sources of lift being needed. There's various different sources of lift. You can have differential heating in the atmosphere. You can have fronts, cold fronts, warm fronts. You can have dry lines. These are not as common across our area, but much more common across the southern plains region. You can also be talking about outflow boundaries from old thunderstorm complexes, kind of setting up a source of lift for new development. And even terrain, especially here in the Ozarks region, terrain can really play an influence on thunderstorm development. So bringing those 3 ingredients together with wind shear in the atmosphere, that's where we really start to see that conditions may be conducive for thunderstorm development, some of which may become strong to severe. So wind shear is essentially the rate at which wind velocity changes through the vertical atmosphere. So the best way to take a look at this on this image on the left-hand side, no shear would be that updraft cloud on the left-hand side, where essentially the updraft goes up, but with time, since it does not have a separated downdraft region, it will essentially just collapse on itself. So we'll talk a little bit more about that later, but that's going to generally be what we see with our pulse summertime thunderstorms. Your single cells that just kind of go up and eventually collapse on themselves due to the lack of wind shear. But this image on the right-hand side there, that shows a sheared environment where you see that the wind velocity changes, whether with speed or direction, through the vertical part of the atmosphere. And essentially what is happening then is your updraft gets tilted, and then you have a separated updraft and downdraft region, and this thunderstorm is then able to become more organized and sustain itself for longer periods of time. Other parts we take into consideration when forecasting severe weather is assessing the weather models. We use well over 100 different weather models in the National Weather Service on a daily basis for our forecasting, especially when it comes to forecasting severe weather. And each one of these models vary on their input and their output. And essentially the forecasters use this different model, agreement, consistencies, different biases that the models may have to essentially analyze the environment with other factors when looking at forecasting severe weather. Additionally, we also, have started to dig into the approach of probabilistic versus deterministic. So instead of looking at just a straight run of what a model output may have, we're also starting to dig into the probabilistic part. So this is, there's a 40% chance of hail here versus a 60% chance of hail here. So really digging into those probabilities gives us a better idea of how to message things and forecasting severe weather. And overall, that's looking to enhance the message for messaging as far as severe weather goes. So now let's take a look at the NWS severe weather products. Some of you may be very familiar with all these different products we issue at the National Weather Service, everything from outlooks to watches to the warnings phase. So what do all these different areas mean, different outlooks and watches and warnings? So to begin with the thunderstorm outlook, this will be issued typically several days in advance, and it's going to be your time to prepare. It gives you a heads up, start to put your plans into place. So we'll dig a little more into this on the different outlooks that are issued by the Storm Prediction Center. But in this particular graphic there, you can see there's a marginal and slight risk that is overlaid over the area. And then once we start to get closer to the event, now we're talking 2 to 6 hours in advance. This is the day of the event. And this is when your watch phase is going to occur. We want you to really monitor the weather closely in this time period, because now conditions are now conducive for whether that be severe thunderstorms or even potentially tornadic storms with tornado watches. And then finally, the warning phase. This is going to be typically 10 to 60 minutes in advance. And this is when the conditions are now conducive for the potential tornado or hail. There's something we're seeing on radar that, in fact, we believe something is going to be occurring or is happening already, whether that be wind gusts, damaging wind gusts, large hail, tornadoes, all fall underneath those different warning criteria for taking action and taking the proper shelter. So as I mentioned with the watches versus warnings, the watch phase, one way to compare that is being prepared, while the warning phase is when you take action. So the watch phase, conditions are favorable. Make sure you have a way to receive weather warnings, and you want to continue to check for forecast updates, have your shelter planned. And then when the warning is issued, that's when the potential danger is imminent. You want to take shelter indoors immediately. If driving, you want to find the nearest shelter. And you're also going to continue to follow that forecast through the warning phase to the end of it. So looking at our criteria for severe warnings at the National Weather Service, severe thunderstorm warnings will be issued for winds greater than or equal to 58 miles per hour, hail greater than or equal to 1 inch in diameter or the size of a quarter. And we also use severe IBW tags, or impact-based warning tags, at the Weather Service now. So base, considerable, and destructive are your 3 different tags that will be found at the bottom of a warning. So your base is generally going to be for your, your thunderstorms that are reaching severe criteria, but are not necessarily over the top as far as severe. Then you get your considerable. That's when we're starting to really ramp up our wording, whether that's, you're talking about winds maybe approaching 80 miles an hour at this time. Maybe you're starting to see a signature for hail much larger, approaching baseball, for example. And then finally, destructive is when, that's when you're typically going to see this tag used in something, for example, as a derecho, where you have, a huge wind threat of destructive winds over a large area would be a good example for that. Tornado warning. This is when a tornado is happening. We use different tags as well with this. Typically, we're going to have in a tornado warning as well, whether it is radar detected, radar confirmed, or whether it's reported on the ground. These are particular things we really want you to pay attention to, both as a storm spotter or just as generally watching the weather. Make sure you pay attention to what different language we are using in these warnings to kind of give you a better idea of what we are seeing, to add confirmation to what we're putting in the warning at that given time. And then lastly, a flash flood warning. This is going to be issued for intense flooding. This is when your water begins to rise out of its banks, and we get flash flooding pretty common across the Ozarks region. But it also can be attributed to other things such as dam breaks and ice jam breaks, which are much less common across our area. So as I mentioned on the Outlook phase, the Storm Prediction Center has this particular graphic, if anybody is not familiar with. So this highlights your different Outlook stages. Thunderstorms being your lowest when there's no particular label. And then generally a 1 through 5 criteria you're looking at here, with 5 being the highest, 1 being the lowest. So 1 being your marginal outlooks, you're talking about isolated severe thunderstorms possible. And then you can see as that progresses to the right there, we really start to enhance our wording. For example, tomorrow we are in an enhanced severe weather risk for portions of our area, and that means that numerous severe storms are possible. So they're going to be more persistent or widespread with a few intents. And once you start to see us push higher in our outlook phase, the more rare high and moderate outlooks, that's where the widespread severe storms are likely, and the particularly intense and dangerous storms can be expected in that. But with any of these given outlooks, severe storms can pose a threat to daily life, and take action as needed with any particular watches and warnings that are issued under any of these given outlooks. So how do we issue warnings at the National Weather Service? We use a program called WarnGen, and essentially the radar forecaster is drawing these polygons based on various factors such as storm speed, movement, what further development they're seeing, all the different training that goes into this, into issuing the different polygons. And then these warnings are then disseminated through various sources such as broadcast media and weather radio once we click the issue button on our end here at the National Weather Service. So now we're going to dig into what the storm spotter really needs to be a storm spotter. What does it mean to be a storm spotter? So the first section of that is going to be identifying the different storm types and futures. So at the National Weather Service, you may be familiar if you've ever been by our office or any other offices. We have this big, what it looks like a soccer ball on stilts. So that is our radar. There are over 100 of them across the country. That's what we use to look at radar. It sends an outbound pulse of energy towards the thunderstorms, and then that energy is then reflected back to radar, and then voila, there you go. To break down the algorithms and everything for you, that's what it's going to give us back on our screens inside the office. So then we also have satellites. We have several satellites stationed in our orbit across the world, and those particular satellites give us pretty cool look at various things such as how are the clouds developing, where are they developing, the greatest instability, all sorts of great information that we can take into effect with issuing our warnings and such. So the different storm types, so we're going to take a look at here. The first two here we won't focus too much on, spend too much time on. That is going to be your single cell or pulse thunderstorms. That's typically what you're going to see during the summertime when you have just ample heating across the area, and we talk about a pop-up thunderstorm or two possible. That'd be your single pulse thunderstorms. Multi-cell are going to be your more widespread, in kind of pulsy in nature thunderstorms, but they're going to be a little bit more widespread in nature, so to say, and cover a little bit larger area. And then the two that we're really going to dig into this evening are going to be our squall lines. So this is going to be essentially a line of thunderstorms. And then our supercells. These are going to be the ones that kind of look like a kidney bean with your little bit of hook echoes, as they like to say. So that is what we'll be digging into this evening. So first, taking a look at the pulse single cells. There's an example on the left-hand side on the radar, what that would look like on radar. Typically, your hazards with these pulse single cells are going to be hail. You can reach some severe criteria with some of these, especially. Some gusty winds, some lightning, always going to be a threat in any thunderstorms. And you can also get your heavy downpours with this, and even some flooding, especially if they kind of sit over the same area for a long period of time. Here's what multi-cells would look like on radar imagery. Just, kind of messy, but nothing's really too organized. There's just some cells here, there. You're gonna get some lightning with these without a doubt. Gusty winds, hail are also potential with these. And then once again, heavy downpours and flash flooding. So the other two that we're really going to dig into, to begin with, the squall lines. Generally with squall lines, your hail threat's going to be for smaller hail, typically not going to be the larger, your baseball event, your baseball size hail events. You're going to see much smaller hail in these squall lines. But the big things that we really want to focus in on squall lines is these are going to be capable of producing straight line winds over a large area. And then they're also going to be capable of producing your generally shorter lived and generally going to be rain wrapped tornadoes. Then just like with any other thunderstorm activity, lightning, heavy downpours, and flash flooding cannot be ruled out with squall lines. And this is also what we refer to as being associated with bow echoes along squall lines. So looking at a schematic diagram of what a squall line will look like, the red arrows here on the screen representing your updraft region up ahead of the squall line, while your blue lines represent your downdraft region. First area I want you to note here, which we will take a closer look at in upcoming slides, is your shelf cloud. This is going to be at the leading edge of the gust front here. So this is going to be associated, when this area overcomes you, this is where your straight line wind potential is going to be within a squall line. And then further back behind that region, the area shaded in yellow, this is where generally behind that gust front and shelf cloud is where your potential tornadic development is going to be. And then, like I mentioned, generally these are going to be rain-wrapped tornadoes, so not going to be ideal from a storm spotter aspect of identifying a tornado so often in a squall line, but more so identifying that shelf cloud future and the potential of straight line winds as that approaches. So this particular slide here, the left-hand side, we focus in on reflectivity on radar. The right-hand side focuses on the velocities on radar. So you can really see with these, on the left-hand side there, you can see two arrows kind of pushing into this particular squall line. And in that region with the dashed white line, that would represent where your bow echo region is, so to say. And that is where your strongest winds are going to be right along those, that leading gust front, leading edge where your shelf cloud would be as well. And you can really see that in velocity as well, where those reds meet the greens. that's where your strongest winds are going to be with that associated squall line and the bow echo region. So now let's dig a little bit into supercells. So what are your hazards with supercells? This is pretty much going to be everything with supercells. The one difference being from squall lines is they're not going to cover as large of an area, so to say. They're not going to be over a wide swath, but you can get multiple supercells covering an area, which can be just as destructive or more destructive than a potential squall line would be. So with supercells, we're focused in on large hail. Your supercells are really going to be the ones that produce your massive hailstorms. So we're talking about, your baseball to softball size hail is possible with very strong supercells. You can also have straight line winds within supercells. Lightning and heavy downpours, flash flooding, those are always going to remain a threat with supercells and thunderstorm activity. But then also the big key difference here from the squall lines is the supercells are going to be what typically produce your long track tornadoes. So for example, going back to the recent December event in 2021 across portions of western Kentucky and Tennessee region, that region was impacted by a long track tornado from a supercell. So that's where we're going to see those long tracks and long-lived, possibly intense tornadoes. So taking a schematic diagram look at a supercell, this would be looking to the northwest at what a particular supercell would look like. Once again, the red arrows kind of denoting your area of updraft region, with your blue areas denoting the downdraft region. Also take note that that updraft region is going to be rotating in a supercell. So every supercell is going to be rotating and has a mesocyclone that we identify. And then you're also going to have your other similar features that you see with a squall line, such as a shelf cloud is going to be apparent on some supercells. And you're also going to have a wall cloud, potential of seeing a wall cloud. And from that particular wall cloud region would be where your tornado would develop as well. So we'll dig into a little more of how you would best identify those wall clouds and shelf clouds coming up in the next few slides. But the big thing I want to hammer home here when looking at this particular supercell, you're viewing this looking towards the northwest from the southeast, and that is keeping in the right-hand rule in mind. You want the rain and downdraft region to the right of you, and you want the updraft region to the left of you where the potential tornadic development would be. That's going to be a storm spotter safety 101 thing to keep in mind through this whole presentation, and it will come up several more times throughout this presentation to always keep that right-hand rule in mind, keeping that downdraft region to the right and updraft region to the left. And that positioning will keep you safe as the storm moves perpendicular to your field. So on radar, there's another example of what a particular supercell would look like with its familiar hook echo back into there where the tornadic development would be. And looking at that from a ground standpoint, viewing a particular supercell, this particular spotter would be in a good positioning at this point. Maybe a little bit too close for comfort, a little bit too close potentially for storm spotting, maybe a little bit further back would be ideal in this positioning. But in general, they are keeping in mind the right-hand rule with that downdraft region with the darker cloud where you can see the rain falling to the right, and then the updraft region there on the left-hand side of that image. So here's another look at a supercell. Looking at reflectivity on the left and velocities on the right. As I mentioned, on the reflectivity on the left, you will want to look for the possible tornadic development back into that hook echo region where it kind of hooks back around, circled in white there on the left-hand side. And looking at that same cell on velocity on the right, you can see that that is also going to be the area where the reds and oranges and yellows meet the blues and greens. Where those areas come together, that is where the radar is essentially diagnosing that there is an area of rotation in there. So that is what we are using at the National Weather Service to show, or to essentially analyze that there's an area of strong rotation there and potential tornadic development. In this particular case, there was a tornado on the ground with this given case as those velocities come to meet together there. So now we'll dig a little more into those different storm features that I mentioned through the last few slides. Take a look at some more shelf clouds, some wall clouds, and funnel clouds, and eventually look at even some tornadoes here over the next few slides, including some videos. So I will play this short video here of a shelf cloud coming in. This is over the St. Louis region, St. Louis Arch. Play that one more time. You can really see how it has that shelf-like appearance with the shelf cloud that has given its name. Really to see how that contrasts against the rain-cooled area behind it, where your strong winds are going to be. So a shelf cloud is going to be officially be a lowering on the leading edge of the rain-cooled air, or the downdraft region. It's typically going to expand across much of the horizon, and it's not going to be associated with tornadoes. So you can get some scary looking clouds, so to say, along that leading edge of the shelf cloud, but that is not going to be your tornadic region. As I mentioned, your tornadic region is going to be just behind that shelf cloud area and generally going to be rain wrapped. So your shelf cloud is going to be associated with the leading edge of that gust front, the gusty winds. Here's another great diagram of looking at a shelf cloud moving across the plains region. This particular storm would be moving from left to right in this picture, and you can see that the warm, moist area in the red arrow would be kind of being pushed over the top of it, and then with that downdraft, rain-cooled area pushing down towards the ground and outwards, that's going to create that shelf-like appearance, sloping down, moving away from the rain. So let's take a look at some wall clouds now. Your wall clouds are going to be the isolated lowering, and it's going to be a large area of upward motion in the updraft region. So some things to keep in mind with analyzing a wall cloud or calling in a wall cloud report. Look for things such as, is it persistent? Is it rotating counterclockwise? Those are going to be the big things that help us know, in fact, that what we're seeing on the ground and on radar is, in fact, ground truth. So movement does not equal rotation. So making sure having a wall cloud will also not always mean that there's a tornado will form, but that will generally give you a good idea that a tornado will be possible in that given area. So here's a video of a wall cloud. Amber, Oklahoma in 2015. Wait for that to load here.
Wow.
So I'll go ahead and pause that there, but that is a great video there that shows you, he's checking off all those check marks there. It's a persistent future that he's seeing. It's rotating counterclockwise, and it's generally going to be, it's your area of large upward motion. So this is what we would want you to report to us as a wall cloud in the lowering that you see from the base of the thunderstorm. Here's an example of some more wall clouds. Left-hand image there, you can see that isolated lowering from the base of the thunderstorm. The potential tornadic development would then come from beneath that. Here's another isolated lowering. Though I don't have this one, I don't have a video on this one, so you can't definitely say that it was rotating, but this was, in fact, a wall cloud picture that was sent in to us and was rotating. So make sure to always denote that it was, in fact, rotating with it, and that it was not actually just a scary-looking cloud that was on the leading edge of the thunderstorms. So now funnel clouds. Your funnel clouds are going to be a rotating funnel-shaped like cloud. They're going to be extending downward, but not in contact with the ground. So they're rotating at the base of the thunderstorm cloud or updraft, and you're going to be it's going to be coming down from your wall cloud region. And this is going to be an area of upward motion. Once again, is it persistent? Is it rotating? What is the different appearance that it has? Those are things we want you to report to us with a funnel cloud. Show you a quick video of a funnel cloud here. So as you can see in this particular video, that feature continues to rotate. You can even see it starting to extend down a little more there towards the end of the video. So it's definitely a persistent rotating feature that we would want you to report to us as a funnel cloud, because it is in fact not in touch with the ground at this given point to lead to what eventually be a tornado. So here is a couple of more examples of different funnel clouds, different shapes and sizes that they come in. Another great example there of a tornado or a funnel cloud before a tornado eventually touched down. So finally we get to what everybody loves when it comes to talking weather, tornadoes. So what exactly is a tornado? A tornado is going to be defined as a violently rotating column of air extending from a thunderstorm to the ground. Precursors to a tornado, you're going to have your rotating wall cloud or a funnel cloud, or a funnel cloud. It must be attached to the cloud base, and it has to be in contact with the ground. This is where we want you to confirm that there's debris being lofted, whether that is trees that you can see are in fact being snapped and uprooted, being lofted into the air. Are you seeing power flashes to confirm that it's being in contact with the ground? Those are all great things when reporting that a tornado has in fact touched down. And the cloud movement does not necessarily mean rotation. Keep that in mind when looking for tornadoes. Here's another great example of a tornado on the ground there. And another one here crossing a highway. Keep in mind that just like the funnel clouds, the tornadoes are going to come in all different shapes and sizes. And, don't get caught up too much in, what the different sizes and shapes are necessarily, because, any given tornado has the potential to produce life-threatening damage, whether that be, a weak or short-lived tornado or a larger destructive tornado. They all have the capability of being life-threatening. So here's a couple videos to look over of whether they are tornado or not. So I'll play the first one here. It kind of gives you the way to answer there, unfortunately, on the YouTube title. That just went away. So notice in this video there is a little bit of lightning with it, but something we're not noticing with this particular video is there's not any rotation with this. So for this particular example on the left video, it was in fact just a rain shaft. So the downdraft region where the rain's just collapsing out of this thunderstorm. Here's another video.
8:18 p.m. in the Stop and Shop parking lot, July 24th. Moving. Now that's a scud bomb if I ever saw one. Bet there's going to be funnel cloud reports with this. No rotation, though.
Oops, so we'll go back to that. So great job by the narrator of that video, shooting this video on that one on the right-hand side there. You can see he mentioned that, even though it kind of, you see an isolated lowering and kind of looks scary, it looks like it can, very well, if you just snapped it one picture with it, it can be something that looks like, possible beginning of a tornado. But in fact, he denoted that there was no rotation with this particular feature. And in fact, it's just a scud cloud, so to say, moving across the sky there. So when we're talking about spotter positioning, there's a lot of different things to keep in mind. The first most important thing is always having a situational awareness, whether that's of where you're at, what the atmosphere is capable of producing that day. Have situational awareness of other spotters that are on the road. How many other spotters are chasing? Is it possibly going to produce congestive roadways, and road networks are going to be congested and backed up? So that's important to keep in mind with situational awareness when it comes to spotting storms. Other things to keep in mind: where's the location of the storm with respect to you, and which way is that moving and propagating? Where's the location of the other spotters or other people you're spotting with? Are they in possible harm's way, or are you possibly in harm's way? And make sure you're always looking perpendicular to storm motion, so that you can keep in mind that right-hand rule of keeping that downdraft rain region to your right and keeping that updraft region where the possible tornadic development is to the left-hand side of your view of vision. And that will help you keep you safe in the storm spotting. So we will launch poll number 2 here. Which spotter is in the correct positioning to spot a potential tornado on this supercell? Corey will be launching that here for us here. So the answer, or the possible answers, are A, number 1, denoted there by kind of out here in the leading front of this thunderstorm. Keep in mind this thunderstorm, I should mention, is moving towards the right, directly toward the right, so it's moving east. Storm spotter number 2, situated just to the southeast there, or storm spotter number 3, just behind the leading thunderstorm, moving toward the east.
Okay, we'll wait here for a little bit. Got about half the people that have voted so far. All right, most people have answered by now. I'm going to close the poll, and vast majority said number 2.
That would be the correct answer. Thanks, Corey. So let's take a closer look at, I'll go over here, what each particular spotter would be seeing in their particular position. So storm spotter number 1 is clearly going to be in the worst possible position in this given scenario. This cell is moving towards the east, towards the right in the image. So this particular spotter, number 1, would be not only being overtaken by heavy hail or heavy rain, but potentially large hail at this point as well. And any given tornado heading towards them would potentially be impossible to see, as it'd be rain wrapped from their field of vision. Storm spotter number 3, while they are behind the actual thunderstorm as it moves off to the right or to the east, they are still in a potentially very dangerous spot there from a storm spotter positioning. One being a possible tornado could have just moved through that area, so they could be in a dangerous area with debris, power lines down, for example, but they could also be in the path of additional thunderstorms developed behind that. Is there more cells following this particular cell? So that leaves us with spotter number 2, being in the best positioning here. They are situated looking from the southeast towards the northwest, where they can really get a good field of vision, looking towards that potential wall cloud, funnel cloud, tornadic development region. So let's dig into sending storm reports. What we all want you to send to us when you're storm spotting out in the field. Keep in mind, reports can save lives. Reports that come in as the storm is in progress are much more valuable than reports that come in hours after the storm is done, because these storm reports can, help the warning decision maker, potentially keep the warning going. They're getting ground truth that, in fact, this storm is producing large hail, or it has produced a wall cloud and funnel clouds. It may, in fact, keep the warnings active and keep them updated with valuable information. but also broadcast media relays reports. So it gives a better idea of who's in harm's way, what this storm is capable of producing. So when keep in mind what to report, hail. So we're looking for reports of near severe limits or greater. So this is once you produce, once you get towards 1 inch in diameter or greater. And we want you to give us your hail measurements in terms of coins or balls. So whether that be quarters, golf balls, baseball, softball, all for different examples there. It's a good measure to keep in mind. Damaging winds, we're looking for, if you can't give us a measured speed, we're looking for the damage. Tell us what you see, what the wind did, when things are safe to do so. So this includes tree or limb diameter. What is the health of the tree? You know, was it a rotten tree that got broken, or was this a, you know, really strong hardwood tree that was broken and snapped? Or was it potentially uproot? Tornadoes, keep in mind the different rules of some that we went through. You know, is there funnel clouds? Is there rotating wall cloud? Is there damage that you're seeing with it? Power flashes? All great information to report to us. And then when it comes to flooding, make sure to report washed out or flooded roadways. Rain measurements are always important for us. So moving forward, with the hail, as I mentioned, anything greater than a quarter or 1 inch in diameter is going to be severe. And pictures are worth 1,000 words. You know, if you can send us a picture, if you measuring different hailstones from outside when it's safe, that would be tremendous with using rulers or comparing it to different size objects. Reporting wind damage, you know, pictures, once again, they really speak to what essentially happened, and it makes it easier for us to, you know, kind of analyze from our standpoint too, you know, of what we're seeing on the ground is ground truth. When reporting tornado or possible tornado, keep in mind, is it rotating? Is there a wall cloud or funnel cloud? Is there debris being kicked up? And then finally, kind of wrapping it up with the flash flooding, you know, is there flooded, closed, washed out roadways? And then once again, pictures tell a lot. So continue to send us in those pictures. And when reporting, some good who, what, when, where to keep in mind. Let us know who you are, what occurred, when it was, and where it was. So you don't have to necessarily, if you don't feel comfortable sharing the exact address with us of where something occurred, but give us your reference to the nearest town. You know, I'm 2 southwest of Springfield, for example. That's great information for us to kind of pinpoint where that particular severe storm is potentially occurring. And make sure to use the proper terms that have been analyzed over the past few slides here. Do not exaggerate. Remember that lives are at risk here. And remember to always follow up if necessary. That you know, if you don't actually have the report yet, of, you know, potential damage in a town, but you kind of heard of it, you can always follow up with us. That will also help. There's many different ways to send in these storm reports to us. You can tag us on social media, or you can even call us. So I will, the reference sheet here will actually have all this information as well. But if you want to jot that down, there's a number to call here at the office. To call in those storm reports. You can also contact us by email, tag us on Facebook and Twitter. Those will be quick ways as well to get reports to us. NWS is a great way to send in reports. That is the link there in the middle. As I mentioned, this is also on your reference guide that I will be leaving everybody with today. And lastly, the MPing app. If you have not downloaded this on your phone, this is a great opportunity to send in storm reports to the MPing app, which is a project that has been developed through Oklahoma University that will send us reports directly as you put them into your phone and submit them. So here's how you submit storm reports to the MPing app for anyone interested. You would select the report type, select what you're seeing, hail, wind damage, tornado, and then you just simply submit that report to us. It'll tell you that it was successfully submitted, and you'll see it show up on the map. And that also shows up on our end as well, so it's a great resource for sending in storm reports. So we will launch the final poll here with one more section to go after this. So poll question number 3, what is the most important thing to keep in mind when storm spotting in the field? Is it A, safety, B, getting the report, or C, getting the best picture?
All right, getting most of the people reporting already. 1% of the whole group says best pictures. About 1 or 2 people says that. Otherwise, 99% or more said safety.
All right, thanks, Corey. The correct answer is safety. Always keep in mind that storm spotter safety positioning when you're out in the field, and always remember that your life is more important than anything with that storm particularly coming in. So severe weather safety and preparedness, the last section here, just going to kind of take you through all the different avenues available for everybody to use, all the different resources. First off and foremost, you have weather.gov/Springfield. This will take you to our website. Lots of great information on here, whether it be this particular map on the left-hand side where you can get a point-and-click forecast for any particular location. You can also click on our weather stories down there. The weather stories provide a great overview of what what our main messaging is. What are we highlighting, whether it be severe storms or thunderstorms or excessive rainfall. The weather story tab is a great resource. Another great resource when analyzing potential weather threats is your experimental graphical hazard weather outlook, or we reference this as the HWO. This is a quick overview with the chiclets there on the right-hand side that gives you an idea of what your different threat levels are for any given hazard over the next 7 days. Another great resource that we will typically only be issuing these for higher end events that we're expecting will be your Decision Support Services Packet, or DSS packet. This will kind of encompass what you're seeing on our weather stories, but also provide some additional detail of potential weather hazards and threats over the next couple days. And then finally, just follow us for all the different weather safety information. Whether that's FEMA resources we share, weather service resources. There's so many different great people to follow out there when it comes to getting weather information, safety graphics, that is, and preparedness information. When it comes to tornado sheltering guidelines, make sure you always keep these in mind. These are great recommendations from FEMA, showing everything from the worst and the bad options there on the left-hand side in the red, all the way to the good and best options, with your basements and your FEMA safe rooms if you can. But there's going to be times where some people are in these tougher scenarios of the worst and bad options, whether that's in a vehicle or large open rooms. That's when you're putting your plan into action and being situationally aware of the potential hazards coming up is really important down the road. So bringing that all together, where do you guys play a part as storm spotters down the road for us? We're issuing the warnings here at the National Weather Service, but where you really play a key role is that confirmation part. What we're seeing, the ground truth. The warning's been issued. The broadcast media is showing it on TV, showing you where the areas of potential hazard are. But getting that ground truth and confirmation, is very valuable information that can be life-saving in the end. Just a reminder to never put your life at risk to get that report. But when possible, whether it's from your house or such, to send us that report is very valuable information, and making sure that everybody takes the proper shelter necessary. So I will leave with this particular slide here with some information our website, our call number, contact number by email, Facebook, and Twitter. I also want to encourage anybody on here that's part of an organization or group to become a Weather Ready Nation ambassador. This is a great program. Does not cost anything. You don't have to go to any kind of meetings or such like that. Essentially what a Weather Ready Nation ambassador is somebody that collaborates with us at the National Weather Service and shares, the Weather Ready Nation message of being resilient and building safety messages, whether that's something as simple as sharing, safety plans of, what are you going to do to take shelter from a tornado. That's what it means to be a Weather Ready Nation ambassador. And we encourage everyone that is part of a group or organization to sign up at the weather.gov/weatherreadynation or WRN/ambassadors. Or you can also reach out to me. This recording of this particular virtual webinar will be available on our YouTube page at youtube.com/NWS Springfield. And there's also a lot of great information. I'll show here on my screen here. This is the guide that I'm leaving everybody with here today, the Storm Spotter reference sheet. Lots of great links to click on this particular guide with our call information, email information down here, our Twitter, Facebook, YouTube, and our NWS page on these icons, and also some great Storm Spotter safety information here, kind of summarizing some of the different things that I went through today to print off and use whether you want to or not on the road. And another great resource, going to our webpage here, you can see that there is a tab for 2022 Virtual Storm Spotter Training. And if you click on that particular tab there at the top, you'll see that you have all the different registration for these virtual webinars. But there's also great resources on here, whether that be the reporting basics that we mentioned, our reporting information, what to report to us, the different hail sizes, wind speeds, great information on there, as well as some different spotter resources, and even some additional training for anybody that's interested in doing some Skywarn spotter training through a course developed by a program called Comet. This is a great additional resource for additional storm spotter training for anybody that is interested in that. So that will conclude our presentation for this evening. As I mentioned, my name was Kyle Perez, meteorologist here, and we'd also like to thank Corey Rothstein for helping out this evening as well. And I will go ahead and pass on to him if there's any additional questions that he has to pass on for me to answer here at the end.